We are in our last set of notes for this unit. We're going to do these notes, a couple homework problems, a couple labs, and we will be ready for our last major test of the year. So acid and base titrations. What we're trying to do here is we are going to have a known solution, okay, and we are going to have an unknown solution. So we're going to have something that's unknown, a molarity, a concentration, and we're going to try to figure out through this acid-base titration lab, what is that molarity? So to do that, we need a known molarity, which usually is going to be for us an acid, but it could be an acid or a base. This is referred to as your standard solution because it's a known molarity, and an indicator, and the indicator that we're going to use is phenolphthalein. We know that phenolphthalein from our other lab, it doesn't do anything to an acid, but as soon as it gets basic, and that gets up to about 8.3, then it's going to change to a pink color. Now, here's what we're going to try to do. So it says place a predetermined amount of acid solution into an Erlenmeyer flask. Place a few drops of our phenolphthalein in our case, but it could be a different indicator. And says place a base solution into the burette, and this is a process we'll go over. Slowly allow the base to flow out of the tip in the burette into the acid. So it's important for you to understand exactly what we're doing here. So we've got our beaker full of possibly water, possibly not, just depends on what's in there. But remember, it is when we're putting in our known solution, our standard solution, it's going to be mixed with water anyway. It's already going to be diluted, right? So let's say we have our acid. So when we put in our acid, remember it's going to break apart, right? Our hydrogen is going to break apart and form our hydronium ion, and our chlorine is just going to be sitting around in there. So if that is going to come in, right, we're going to put in a certain known amount. So what is that amount going to be? That's for us to decide how much volume we put in. Oops. So let's say that for every 1 molecule of HCl, it's 1 mole. Now we know that's not true. 1 mole is really 6.02 times 10 to the 23rd molecules, but let's just say it's a 1-to-1 ratio. For every 1 mole, there's one molecule that we put in. So we put in 2 moles, right? I put in 2 of these HCl's and they broke apart. Well, when we go to add in our base, we're going to add this in and it's going to be an unknown solution. So what we're really doing in our neutralization reaction is that when we put this in, right, our hydrogen and our oxygen, which this really should have been green, not purple, is going to bond, take this hydrogen from here, and we're going to get water. Now remember that this chlorine here is negative and this sodium is positive, so they're going to join up. Well, if you look at our water now, or our solution, what you see is you see a hydrogen, right, or H2O, 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 H2O. There is our H3O plus, or hydronium ion in there, and there's still this chlorine. Well, because there's this hydrogen in there, our solution would still be acidic, right? Our indicator wouldn't have changed colors yet. So if we keep adding in more NaOH, right, if we add in more of these, which I kind of got rid of them, what were we at? We were kind of like, we were like this, right? So if I start adding those in, well, when we add those in and they start bonding, well, it's still acidic, right? We have our hydronium ion in here. Well, if I add more base, then it's going to keep taking that hydrogen ion, forming water, and then forming our salt. So now what do we have? We have salt water, right? Every single thing is either water or our salts. And so now our acid has been neutralized. There's the same exact amount of hydrogen ions that we put in there and the same exact amount of hydroxide ions. And so because the hydrogen bonded to the hydroxide, we are neutralized. And so hopefully, basically that's the goal, is to get that to neutralize and then make some calculations to figure out how it works. Okay, so, and we'll go over this, right? We're gonna put in our, we were putting in our base, we were swirling it around to make sure this process happens, that the hydronium ion finds that OH hydroxide ion so that they bond together and form water and form salt. And so we continue swirling that flask every time we put in our base. And then at some point, we're going to get a color change. And when that color change happens, we're going to assume that this is neutralized. Now with phenolphthalein, it's actually going to be slightly basic, but that's the best we can do with phenolphthalein. So at this point, you've reached your endpoint, and these are two key terms that you'll be asked about on the test and the final. You've reached the endpoint of the titration when you see the color change. So endpoint is when your indicator changes color, and the equivalence point, you're hoping that this is the equivalence point, and that's like I was displayed up here. That is when you've added the exact same number of hydroxide ions to hydrogen ions so that everything is just salt water. So looking at the math, um, we are going to be given a number of different things. We're going to put in a certain volume of our standard solution that we know the molarity, and then we're going to start adding this base through the burette until they neutralize. So we're going to, by the time we're done with the lab, we will know the volume we put in, the molarity of the acid we put in, and then the volume of the base we put in. And we're going to do these calculations. So here's the 4 steps. You can look at those, but we're going to walk through them. So number 1, write a balanced equation for the reaction. So 25 milliliters of 0.15 molar of our acid into a flask along with the indicator, right? She titrates the solution. So this here is us adding our base from the burette. We've added 34.2 milliliters of NaOH from the burette, and our color changes. So this is the end point. Because the color changes, we're assuming it's also the equivalent point when our hydrogen ions have matched the exact same number of hydroxide ions and it's neutralized, right? We no longer have an acidic or basic solution. We have a neutral solution. So what do we do? Step 1 says write the balanced equation. Okay, right? We know our acid and our base always produce water and a salt because Na is a charge of +1 and C2H3O2 is a charge of -1. They bond in a 1-to-1 ratio. So this also happens to be a balanced equation. So I don't need to do anything there, but if it wasn't balanced, you'd need to balance it. Number 2, find the number of moles of the standard solution using the molarity of the volume of the solution. So basically, I have my standard solution here that I know the molarity and the volume, so I can figure out how many particles of hydrogen ions did I put in there. So using our molarity, our concentration, and our volume in liters, make sure you convert that to liters, I go through and I find the moles. Now remember, this represents the exact number of particles of the hydrogen that we put in, the hydrogen ion. So I know if I converted this to particles, there's that many hydrogen ions in my solution. Well, how many hydroxide ions do I need to neutralize? Well, I want the exact same amount. So I'm going to do a mole conversion. Now in this case, the reason why it's a 1-to-1 ratio is because for every 1 of our acid, we need 1 of our base to produce one water molecule and one of our salts. So because our equation is balanced, I got that 1-to-1. Now if there was a 2 in here, right, then I would have a different value here. I'd have 1 on top and 2 on bottom. But because it's 1-to-1, I leave it 1-to-1. So now I've converted to basically the number of moles of the base that I need to neutralize my acid. Well, if I know how much base that I put in there, and I know the amount of moles of that base it took to neutralize all these hydrogen ions I put in, then I can use my molarity equation again and figure out exactly what was the concentration of my base. Right, so I put in 34.2 milliliters of 0.11 molar NaOH to neutralize my acid. So I was able to figure out how strong or the concentration of my base. So what I'd like you to do is I'd like you to try it. Pause the video here, try it, see if you can go through that process, and then I will show you the answers and you can check your work. So go ahead and pause it and get started. Once you're done, hit play. All right, balance the equation. That was the same. Just be careful again. When you get to the homework, you're not always going to have a balanced equation. It won't always be a 1-to-1 ratio. You change your moles of your standards, your molarity of your standard solution to your moles of standard solution. So I need the exact same amount of particles of my base. So I am going to do my mole conversion. Remember, if there happened to be something like, let's say, a 2 here, then I would want a 2 here. But there isn't a 2 in this particular equation, so I'm just going to do that 1-to-1 ratio. I now know exactly how many moles of my base that I need, and now I can figure out the concentration of that base. Your homework looks exactly the same. You're going to have those 4 steps to walk through. Hope that makes sense. Good luck, and make sure you get it turned in by 7:30 tomorrow.